Continuing with the video lectures for the discrete event information and lecture 2, the next topic is scheduling events. And the discrete event portion in Awesome, you have to schedule all of the events that occur or to occur. And you use this function SCHDL to do this. SCHDL returns an entry pointer, not an entity pointer, but an entry pointer. This means a pointer to an entry in a file. And in this case, it's a special file called the event calendar. You pass it to the event code, the number of the event. In our example, it was 1 or 2, along with the entity pointer, PEInt, or whatever variable you choose to use. So this is where the attribute information is stored. And then a double precision variable associated with the time between the current time and when the event is to occur. So it does return a pointer to the event calendar, which is a SLAM file where the scheduled event is located. You only need to save this, and you must save it in a variable of type entry pointer. You could only need to save this when you want to maybe preempt that event, as in the embellishment to 15.1. For example, we can schedule an event of type 1, so we set up an entity pointer, PE new, with double D time, where we'll store the time interval till the event. So PE new here, we create a new entity and store that entity pointer in PE new. Then we'll set attribute 1 up to a value of 2. Okay, and we do that using this operator that operates on the entity pointer to locate variables inside the structure of the entity. So we can refer to attribute 1 directly this way and assign it a value. D time is sample from the exponential distribution. We can get that just by calling this function. All of the probability distributions are available to you. And then we call function schedule SCHDL with event code 1, PE new for the attributes, and D time for the time interval between the current time and when the next time for the, or between the current time and when the event is to occur. So let's make this a little larger, maybe full screen. Hopefully that pop-up won't occur again. What do you want to do? What happens if you need to keep track of a particular scheduled event? So this is what you'll need to do in the case of embellishment for problem 15.1. You want to keep track of the scheduled end of service event so that you can preempt it if you get an item of higher priority. So we need to set up a variable to hold that or contain the information. So we'll call that PE hold, and it's an entry pointer. So this is where we'll store the pointer to the particular end of service event that is on the event calendar. Note that this should be declared as a global variable up at the top of your code right after you pound define vslam.h. As long as it's outside of your functions, then it will be a global variable and will be maintained as long as your program is running, as opposed to local variables that are declared inside the function that only get maintained as long as the function is executed. So we call schedule with event code 1. PE new is the entity pointer to the information about the attributes. D time is the delta time interval till the event occurs, and we store that in PE hold. So PE hold is an entity pointer, entry pointer rather, and contains the location of this particular event that's on the event calendar. Another concept that's important to get straight in your mind is the difference between rank and entry. Rank is the order in the file. So if rank is 1, it's the first item stored in a file. Entry points to the location in memory where the entry in the file is stored, as opposed to its rank. You can remove entries from files using either of these methods, either rank, which is just its rank number, or a direct pointer to the entry in the file. You can access an entry in files either by rank or entry pointer, as we just said. So, for example, all of these functions are available in Awesome, and they are accessed by file number, and you can remove items by rank. So, an NQ of 1 you're familiar with from the discrete, or excuse me, the network portion. Our move has two arguments. One is the file number and the other one is the rank. So you can remove the first item from a file. Phylum just uses file number. MMLE means the last entry in a file, so its only argument is file number. And MMFE is the first entry in the file, also only has file number as the argument. Sometimes in some of the routines, rather than a file number, you need a file pointer. Awesome allows you to access files in both ways. And we have a function here called simfile pointer, and su underscore fn file, and its argument is the file number. So you give it a file number, it returns the simfile pointer for your particular file. We're talking about now awesome files similar to what we used with QNodes, and also in the discrete event portion, any file number. So here's an example. We set up a variable called file1 pointer. It's of type sim file with the star being the pointer, and we set file pointer equal to su fn file of 1. So it figures out where the sim file, what the sim file pointer is for file 1, and stores that in file 1 pointer. Sim file pointer points to a location in memory where information about the file is stored. If you know you can remove an entry if you know its rank. So we use a function called rmove that has two arguments, file number and rank. This comma is an error, sorry, should be taken out. And it returns an entity pointer. So the file, the entity in the file is actually removed. It's no longer in the file, so it no longer has an entry pointer, but it does have an entity pointer which points to its attribute information. So here's an example of its use. This removes the first entry from file 1 and stores the pointer to the attributes in PENew. PENew is an entity pointer. You can change the values of an entry in a file if you know its entry pointer. It's possible to go straight into the file and into memory and access that information directly without removing it from the file or in any way modifying it otherwise. So we have a function here set up that given you have an entry pointer, will tell you what the entity pointer is for that entry. So the entry pointer just points to the file information, where the entity pointer points to the attribute information. And here's the function su underscore sfnentity. So you give it the entry pointer, and it'll return the entity pointer. And then you can modify attribute information directly using this entity pointer. So suppose we have defined an entity pointer called PEStop. We know PE hold, maybe this was the entry in the event calendar for the scheduled item, and we can locate its entity pointer using this function, and then we can either modify or check the value of any of the attributes. So PEStop is an entity pointer. We use the entity operator to access the attributes. We can either set them to a value or we can even test their value. So this would be a way of testing whether we have a high priority item in the event calendar for, say, a end of service event. We can also remove an entity or an entry if we know its entry pointer. Just like rmove uses rank, this function su underscore file remove removes an entity pointer, but you need its sim file pointer, and you also need its entry pointer. Okay. So, for example, we can define an entity pointer PE stop. We find the entity information and store it in PE stop. PE hold is the entry pointer. Then we can remove that item from the entry pointer using, say, a sim file pointer that we've set up previously. Okay, and store this entity, which is saved in PE stop, in a different file. Okay, so removing an item from a file does not destroy its attributes, or its entity pointer still exists and those attributes are valued. It just no longer has an entry pointer once we remove it, and is no longer part of that particular file. But as you can see, we can put it in a different file if we want to. What if we want to preempt a scheduled event? This is something that you'll need to know how to do in 15.1 in the embellishment. So we want to declare a global variable. This would be after at the top of your code. We declare a variable which is an entry pointer called PE hold. And when we schedule the end of service event, for example, or event, in this case we've used event code 3, we want to save the value that schedule returns, which is an entry pointer, and this will be the entry pointer for that event in the event calendar. So we schedule it. Then we can get its attributes by going through this SFN entity function. This takes the entry pointer and returns the entity pointer. The entity pointer we need to get to the attributes. So we can access the entity that's been scheduled using the entry pointer and store its entity pointer in PE stop, and then maybe save the remaining time for the event by using this function su int time. Su int time is a special function that uses an entity pointer as its argument, and the entities that are stored in the event calendar, which is a special type of file, also have special attributes. In this case, we can access the scheduled time that the entity is to occur and subtract that from tnow, and that'll give us the remaining time for the event until the event is scheduled to occur. So we'll resume this on the next lecture concerned with processing discrete events.